Okay, for the graphing section, this is Math 3 Honors. We are going to be, let's see, wait, hang on, are they here? Wait, Teacher Nicholas Montgomery.
Oh, that's my bad.
So anyway, this is the semester quarter 1, quarter 3, Math 3 Honors final review. Okay, so here we go. First question, graph f of x equals 2x squared plus 12x plus 16. We want to put this in graphing form first. In order to do that, I got to factor, and then I got to complete the square. Okay, so file 2x squared plus 12x plus 16. F. We have here f of x equals 2x squared. 2x squared plus 12x plus 16 plus 12x plus 16. Okay, in order to graph this, let's first like this is all factored out. I think what we want to do is let's go like this. Write it as, even though we can factor this out, it's going to be easier to go 2x squared plus 12x. We hit the plus 16 over here, right? Now, let us factor out the 2 and make this x squared plus 6x. Go like this and hit the plus 16 over here, right? We want to factor out the 2 because when we complete the square, that 2 is going to make it a little bit more challenging for us. Now, to make this a perfect square trinomial, so first we separate the 16, factor out the 2, and we want to complete the square. We take the 6, we divide by 2, and then we square it, right? To make it a perfect square trinomial. 6 divided by 2 is 3. 3 squared is 9. So I'm going to add 9 here, right? But I can't just randomly add 9 to an equation. I got to balance it out. However, I didn't add 9. What did I add? What's the total value I added here? 18, because I did 2 times 9. So I'm going to take away 18 right there. Okay? So, as we write this out now, my vertex form is now f of x equals 2. I completed the square, right? So this is x, square root of x squared is x, square root of 9 is 3. Put my little square there, add it, and then 16 minus 18 is negative 2. And then this is going to make it easier for me to graph. 2 times x plus 3 squared minus 2. Any questions on how I got that? So that's my actual graph that I'm going to graph. So let's go ahead and put this here. 2 times x f of x equals 2 times x plus 3 squared, was it minus 2? I think it was minus 2, right? So now we can graph this. Let's put all our points. We go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. Negative 5. Okay, what's my vertex? Negative 3, negative 2, right? H and K. Negative 3, negative 2. 1, 2, 3, 1, 2. There's my vertex. And because I'm squaring it, I go over 1, up 1, over 2, up 4, over 3, up 9. Except since I'm multiplying by 2, I multiply my ups by 2. So instead of over 1, up 1, I go over 1, up 2. Instead of over 2, up 4, I go over 2, up 8. Right? So over 1, not up 1, up 2. 1, 2. Over 1, 2, up. Instead of 4, I go up 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, up, 1, 2, 3, 4, 5, 6, 7, 8, right? Because I multiply by 2. Now, I may ask you what the domain and range is. Isn't that lovely? So, domain is what? All real hashtags? Yeah, very good. We go all real numbers. So I can plug any number for x. It's going to go that way forever and that way forever. Now my range starts here and goes up. What number is that? -2, y, all the way to forever up, which is infinity. And I put my monsters. And there's your first graphing. Okay, let's go to the next section. Boom. Make sure you practice these. There it is right there in vertex form. Boom. We went ahead and graphed that already, right? So it's nice to know that we were right. Okay. This one you're not going to have to list the domain and range because it goes on forever. But let's go ahead and graph this function, right? F of x is x was 2, x minus 6, x plus 8. Okay. What's the first thing we need to do? Set equal to 0. So for all intents and purposes, because I'm only using the whiteboard, let's say this is equal to 0. In fact, maybe I'll go like this. There we go. Okay, so let us set it equal to 0. Boom. What's my second step? Starts with an F and rhymes with tractor. Factor. And it's already factored, right? What's my next step? Find the zeros. What are my zeros? -2, 6, -8. And let's go ahead and put our numbers here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. Okay. Let's find a random point. We also have to do that, right? So, I think I'm going to plug in 0. That might be ugly. Actually, I should, before I put these here, I might not be able to go up to 5, right? So I should probably erase this. I got to figure out what my scaling is here. I guess we'll do 0. Plug in 0. 0 plus 2 is 2. 0 minus 6 is -6. And 0 plus 8 is 8. Okay. So when x equals 0, plugging in 0 for my x, what is my y? -48 times 2, -96. Is that right? Am I right or am I wrong? Am I wrong? You guys will tell me if I'm wrong. -96 is my random point. So I got to scale it down so I could at least get to 100 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. It's kind of big, but maybe I guess I could do tens. 10, 20, 30, 40, 50, 60, negative, 70, 80, 90, 100. Got to do it this way too. 10, 20, 40, 60, 80, 100. I got to go down to that negative 100. Okay, so now let's test the intervals. Okay, what are my zeros? My zeros are negative 2. There's a 0 there. My zeros are negative 8, 2, 5, 6, 7, 8. There's a 0 there. And then positive 6. Now I'm going to test the intervals right here on the graph so you can see it on the video. But those are my zeros, right? Negative 8, negative 2, positive 6. And let's test our limits, test our intervals. Let's do negative a million. Everything's going to be negative and negative a million. 1, negative, negative, right? So 3 negatives means what? It's a negative. Let's test what's in between. Oh, negative 5. Negative 5 plus 2 is negative. Negative 5 plus 6 is negative. Negative 5 plus 8 is positive. So 2 negatives make a positive. Let's do 0. We already did 0, but 0, positive, negative, positive. I got a negative, right? 1 negative. And then let's test 1,000, a million, 7. 7 plus 2 is 9. 7 minus 6 is positive 1. 7 plus 8 is 15. Positives. We also have our random point, 0, negative 96. I got 0. Negative 96 is 96, right about there. All right, here we go. Here I got negative. Got to hit my 0. Boom. Positive. Hit my 0. Random point there, right? Which is negative. Makes sense. Hit my 0. And then I go positive, and that's all you've got to do. Make sure you get your scaling in. Okay, graph f of x. This is very similar to the one we did before, except it's already it's already in vertex form for us. So let's do our scaling. Hit the scaling on the graph. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, negative 5. And then 1, 2, 3, 4, negative 5. 1, 2, 3, 4, negative 5. Okay, what's my vertex? My vertex is 3, negative 5. So I'm going to hit that 3, negative 5. I got to go over 1, 2, 3, 1, 2, 3, 4, 5. Right there is my vertex. Then I want to go right over, it's a parabola, right? Over 1, up 1, over 2, up 4, over 3, up 9, except I multiply by 2. Over 1, up 2. Over 1, 2, what's 2 squared? 4, so I go up 8. 1, 2, 3, 4, 5, 6, 7, 8. Just like before, over 2, up 8. 1, 2, 3, 4, 5, 6, 7, 8. And then you go ahead and graph it. Domain. What's my domain for the parabola? All real numbers. All real hashtags. What's my range? -5 all the way up to infinity. Y monsters. You could also put y is greater than or equal to -5, right? That also works. All right, next one. Boom, that was pretty straightforward. Now graph this function. List the domain and range, right? What type of function is this? Square root function, right? So we want the square roots. But first, I'll let you guys pause so you guys are set. Before we graph it, let's do the scaling. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, what is my h and k? -5, 0, right? -5, 0. So I'm going to go -5, 0, which would be right there. -5, 0. Over 1, up 1, over 2, up 4, over 3, up 9? No, it's the square root. I want to get the square roots of my overs, right? What is the square root of 1? 1. What's the square root of 2? I don't know. 3, 4, up 2. 5, 6, 7, 8, 9. 1, 2, 3. Oh, but wait, I forgot. What is the square root of -1? Your silence is deafening. You are correct. There is no square root of -1 that we can graph. So, like this. But square root of 1 is also -1. Should I graph the bottom section? No, because we want it to be a function. So, what is my domain? -5 to what? It's so hard to write upside down 8s. Or we can say x is greater than or equal to -5. You guys see how those both work out? You just need to communicate to me, right? It's just greater than -5. The range, what do we start at? 0 to infinity. Oh, make sure you put the line underneath the 0, not the infinity. Domain and range. All right, here we go again. Now I take the cubed root, right? What's our perfect cubed numbers? Do you guys remember cubed root looks like a sideways S? Sideways S. You at home. So, let's do our graphic. I'll give you a second to set it up. Anyway, g of x equals 2 cubed root of x plus 3. Now we want to get our perfect cubes. We got to know those. But first, I'm going to do my scaling. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, -5. 1, 2, 3, 4, -5. Okay, h and k is what? Now, can I get the cube? You're correct. 0, 3. Can I get the cube root of a negative? Yes. Right? So, I don't know if this is going to help you, but my perfect cubes are 1. Cube root of 1 is 1. Cube root of 2, 3, 4, 5, 6, 7, 8. Cube root of 8 is 2. Now I can also get the cube root of negative 1, right? Which is, what's that? Negative 1. Negative 1 times negative 1 times negative 1 is negative 1. And finally, the cube root of negative 8 is negative 2. All right? So, zero, 3 is my vertex. 0, 1, 2, 3. I got it right there, right? Then I get the cube root of my numbers that I go across. Cube root of 1. 1 over 1, up 1. Cube root of 1, 2, 3, 4, 5, 6, 7, 8. What's the cube root of 8? Dos, I heard someone say. I know that means 2 in Spanish. Cube root of negative 1. Yes. Luis, what? Oh, what did I forget to do? Let's edit that on the video so we don't see my mistake. Oh, but I don't know how to edit it, so I'm screwed. Okay, well, whatever. Did I say that out loud? I didn't. Anyway, it's okay. I'm not taking the test. I can make mistakes all that I want. I'm still getting paid. Did I say that out loud? I didn't, did I? Cube root of 1 is 1. Times 2 is 2. So I got to go up 2. Thanks, homies. Cube root of 2, 3, 4, 5, 6, 7. Cube root of 8 is 2. Times 2 is corazon. 1, 2, 3, 4, 5, 6, 7, 8. Cube root of 8 is 2. Times 2 is 1, 2, 3. 1, 2, 3, corazon. Okay, negative 1. Cube root of negative 1? Negative 1 times 2. Negative 2. Cube root of negative 1, 2, 3, 4, 5, 6, 7, 8 is negative 2 times 2 is negative 1, 2, 3, 4. Looks good. Hit it through the points. Up. It's that sideways kind of F. F. When I say F, I mean S. Domain. All real hashtags. Domain goes all the way to the right, all the way left, negative infinity to infinity. All real numbers. Range. All real numbers also goes up forever and down forever. All real hashtags. Domain and range is not that, you guys starting to feel like domain and range isn't that difficult, it's just a pain in the butt to do? Like you can do it, but it's like, why? Why am I doing this? Can I just move on with life? Everything I'm showing you right now, I'm going to give you a piece of paper and you're going to have to graph it and list the domain and range. Then when you're done, you turn it in and you log on to Delta Math and do your Delta Math section. 2 parts to the final. Is that what your question was? Okay. So, all right, homies. Oh my goodness. You like the 3-in-1 graph? Why is this 3? Because you got to graph the function. You got to graph the inverse. You got to graph the line of symmetry. I know. Makes you wish you were taking the chemistry final instead.
No.
Then this isn't that bad. All right, so first we've got to find the inverse. F of x equals x plus 3 cubed. All righty. I'm finding the inverse. F, what happened to mine? I want to do I want to do, does purple show up? Purple. F of x equals x plus 3 cubed. We must find the inverse of f of x, right? So what do? Let's change this f of x to a y. And then let's switch the x and the y. This allows us to inverse everything by solving for y. It helps us keep everything in order and then also do the opposites, right? This one we add 3 first, then we cube. So we'll probably have to take the cube root and then subtract 3, right? But let's solve this and see, right? Who's the loser of the party? Right? The cube root of 3. So to get rid of him, I cube root both sides. Cube root of x equals y plus 3. Now I got to subtract the 3. Because this cube root is only with the x, you do not put it under the 3 because that's going to mess you up big time. Big league. Minus 3, minus 3. The cube root is not with the 3. Cube root of x minus 3 equals y. I got the y by itself. See how it makes a difference? If I kept the negative 3 in the cube root, that would be an h. But it's not an h. It's a k. So, inverse of f of x is cube root of x minus 3. I know. I hear you're yawning. It's painful, but thrilling. Which equals cube root of x minus 3. Let's put in our numbers, shall we? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. Negative 5. 1, 2, 3, 4. Negative 5. Okay, let's do the, we'll make this, which color should we do this? Black? Yeah. What's my h and k for my original function? Negative 3, 0. So I go 1, 2, 3, 0. This tells me I cube my x. Over 1, up 1. Over 2. We do know. We cube it, we're not cube rooting it. Up 8. Negative 1, negative 1, negative 2, negative 8. Did I say cube root? I meant cube if I said that. We can check the video. So, over 1, up 1. Cube. Cube it. Over 2. What's 2 cubed? 8. 1, 2, 3, 4, 5, 6, 7, 8. Negative 1, negative 1. Negative 2, negative 1, 2, 3, 4, 5, 6, 7, 8. And remember, this is what the cubic function looks like, right? Kind of makes sense. It shoots up real fast, goes down real slow. That's f of x. Let's label it so Sensei knows you know what you're doing. That's f of x. Label it f of x. Let's do the inverse function. That's purple. H and k, 0, negative 3, right? 0, negative 1, 2, 3. There's my vertex. So I got to take the cube root of everything now. Cube root of 1 is 1. Cube root of 2, I don't know. 3, 4, 5, 6, 7, 8 is 2. Cube root of negative 1 is negative 1. Cube negative 1, 2, 3, 4, 5, 6, 7, 8 is negative 1, 2. And we know my cube root is kind of like the sideways s or whatever. I don't know what to call that thing. To show we know what it is, let's list it as the inverse of f of x. And then finally, And that's what the two cube root, right? You guys remember that from your test? That's what they look like, the cubic and the cube root. Remember I said inverses kind of look like they're sideways from each other. Now we got to do the line of symmetry, which I'll make it blue. 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, right? And label that y equals x. So I know that's the line of symmetry, but that's pretty self-explanatory because the line of symmetry will always be y equals x. And we have one more, your favorite and mine, graphing logarithms. Yay! Yay, logarithms! Let's hear it for the logarithms. Woo! Yeah. All right, everyone, logarithms. They love it. You can hear them clapping. I don't know if I should film you guys because then I'll get fired for filming you guys without permission. All right. What did you say, Mariah?
It wasn't me, it was Chris.
Oh. All right, let's do the easy logs. What are they? 0, 1, 4. Right? What is the log 4 of 0 equal to? No solution. Right? If I wrote it in log form, what is that? 4 to the what equals 0? Well, nothing, right? So we'll say no solution. What about log 4 to the 1? What does that equal? 4 to the what equals 1? What is that supposed to be? 0. Right? Anything to the 0 power is 1. And then finally, what log to the 4 equals 4, right? Well, 4 to the what equals 4? Yes, Nalea, it is 1. 4 to the 1 equals 1. And that's all we need to know. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. No, should I do it in blue? I'm gonna do the asymptote. At 0, it's no solution. Right? Got that there. 1, 0. Do it in blue. 1, 0. 4, 1. 1, 2, 3, 4, 1. Right? Now, all you got to do is know that it hugs the asymptote, goes through these points, and shoots over here. Pew! Do I ask for the domain and range? Unfortunately, I do. Domain. Oh! What is my domain for this? What's the smallest number here? So confusing. Watch what I put here. See if this makes sense. I put the smallest number is 0, and the largest number is infinity. Now I know what you're saying. You're saying, but Sensei, it can't be 0, right? So why would you put 0? Watch this, young men and women, gentlemen and ladies, ladies and gentlemen. Ladies and gentlemen. Oh, I thought you didn't hear me. I was going to repeat it. What did I do? Can you see that back there? What did I do that I normally... What did I not do that I normally do? I didn't put an equal to 0. X is greater than 0. It's not equal to 0, but it's greater than 0. That shows it will not equal 0. And the range, I'm running out of room here. Shoot. I guess I'll erase it. I'll erase this. Oh, sorry, you guys. I don't know, I feel like I should leave that there, though, for the video people. On the other side over here, but I got all this. Maybe I'll go like this. Oh, shoot. Oh, I'm messing up. I'm going to do a section here. Range is, well, range is pretty easy. What is range? All real hashtags. All real hashtags. Because I can plug in any, it'll go up here. I can plug in any number for y, x. And that's all I have to say about that. That's everything you need to know for your final.